right. Morning, everybody. It's Friday, and I'm going to talk about light rays today. I guess 2 days ago now, we did a note on sources of light, and we talked about some of the different ways to produce light, and I left you some work with that. Oh, look, this probably drove some of you crazy last time. I am going to hide that. That's a nice change. I also parted my hair in the middle, something a little different. I know, crazy. Okay, so to finish off the week here, what I've decided I'm going to do is do this final note with you. This will wrap up chapter 10 in your textbook if you're following along in your textbook. For after the lesson, I'm going to leave you some pages of your textbook that you can look at and answer some questions on to confirm you've understood the material that's been presented to you this week. And then I'm going to attach an article, which I think is kind of interesting. And it has to do with x-rays and music. And then maybe some little fun other clips. And then when we come back next week, I'm going to give you a Google quiz. So on Monday, I am going to give you just a little confirmation. Once again, some quick questions that you can respond to make sure that you're understanding the material that we're working through. Okay. So let's get started on today's note. We're going to call this, I just made a little note of the things I want to make sure I mentioned, the ray model of light. And so let's write this down here. Ray, oh, not a good choice. Let's just use standard blue pen here. Ray model of light. There we go. Okay. So there's sort of two key components to this. First of all, a model in science is a picture or an image we use to describe something. So we talked about in chemistry the model of the atom, and that's where you use your Boyd-Rutherford diagrams. So the model meant that there was a picture. It doesn't really fully describe the complexity of the topic or the issue or the phenomenon, but it does allow us to sort of at least demonstrate some of the properties that we know to be true and help explain it with an image or a picture. So that's what we're talking about with light. Light is a form of energy. There's two features to this ray model of light. One of the features is that light travels in straight lines. Okay. And so that shouldn't be too much of a shocker to you if you think about your experiences with light and you think about like a wall and then going around a corner, depending on where the light source is in the room, that light doesn't bend and travel around the corner. Okay. So the light is going to come out from the source and it's going to travel in straight lines out from all around that light source, but it doesn't have the ability to bend and shift and go around a turn. When it hits something, it has one of three options, which we're going to talk about later. But for now, understanding it travels in straight lines, and is how it goes through space and how it behaves generally until it hits an object. The second feature to this model is when we draw light, it's going to have an arrow on it. So there's an arrow to show the direction the light is traveling. Okay. So light does have a speed to it. It's a documented quantified speed. I think it's 3.0 times 10 to the 8 meters per second, which of course is incredibly fast. It means that like from the sun to the surface of our Earth, it takes just about 8 seconds for that light to get from one spot to the next. And of course, it was quantified and famously talked about in E equals mc squared, c being the constant for the speed of light, all extra. Anyway, light does have a direction. It travels out from the source. So whether that was an incandescent light bulb or an LED we talked about, or bioluminescence, or anything like that, whatever the source is, when light leaves that object, it travels away from it, and it travels away in a straight line. So this creates shadows. So, well, first of all, let's do this. Let's draw like a little picture of a light bulb to show what the model looks like that. Okay. I'll do an incandescent one. Go old school here. So when this little coil here, this little wire heats up and gives off light, if we wanted to show this using the ray model of light, I don't have a ruler. Well, I do, I'm just not going to use one. You can show, even though the light comes off as energy all the way around, we can just show it like this. Okay, lines coming out from the source all the way around. And we would put arrows on the end to show which way the light is traveling. Okay, like that. All right. The closer you stand to the light bulb, the brighter it's going to be, because you're standing here with your eye. Your eye is what receives light, how you detect light in your surroundings. So you're going to get more of these light rays hitting your eye if you're nearby, compared to if you stand very far away. They'll be more spread out and less impact on your eye at once, so you won't get that same brightness. Okay, so let's say we put an object here. Oh, I don't know, what should I draw? Okay, I'll try and draw a little person. It's probably not the best choice. Stick person, there we go. All right, when the light rays, and it wouldn't be a light bulb, but more like, let's say, be the sun. Let's do the sun up here. Sun. Okay, and it's going down, so it's not directly above, it's setting on the horizon. These light rays, let's take this one for example, are going to come at the person, and let's say that one's going to skim the head, keep going, and then hit the ground behind. Okay. All of these ones that come here, they're not actually going to make it through the person. Light doesn't penetrate through you and come out the other side. So we can just sort of show that. Depending on like what you're wearing, you'll absorb more of these rays and reflect others, but it's not going to go through you. So then what you get behind is what we call the shadow. And usually it's stretched out a little bit. Let's see here. Okay, that you would, this dark spot basically, that you would see behind you on the ground from the fact that the light rays couldn't get through you. You had some go around you, and those light rays hit, and where the light rays couldn't get to, you make this dark pattern as a result behind you. And the farther the sun down, like the farther it goes down in the horizon, the longer it's going to stretch out your shadow, because it, like if this was down a little bit lower, this would skim here and stretch out even farther before it hit the ground, right? When it's like up above, you're not going to have any shadows, because it's going to sort of penetrate down and then like hit more directly on the top or from some different angles, and then you won't get the shadowy effect to the same extent, okay, or at all, depending on how much light there is around you in the environment. You could do this too, like if we did set up a candle like in class. I don't know why I drew that. That's not a candle. Light bulb, fine. And then I put it's like some little dark object here. I'll just do a square. Right. And then I held like a bigger screen behind it. And I let the light bulb do its thing. What I would get is I would get light rays going like this, light rays going like this, and I would create a dark spot right here, or the shadow. Okay, so I hope that sort of explains the ray model, which basically says when we choose to draw light and represent light in diagrams in science, that they're straight lines with arrows to indicate direction. And you can see here the phenomenon of the shadow and how we explain why shadows exist. All right, the next thing I want to talk about are the definitions, the words that we associate with what light can do when it strikes an object. And these are not new words necessarily. So when a light ray strikes an object, there are three options for what could happen. And you can have a combination of these, okay? So first thing that could happen is that it could reflect. Okay, so the light ray would hit it, bounce back off. We talked about that, like with things that appear white, is that the visible light hits it and it reflects back off it. Two would be that the light ray gets absorbed. Like if you're wearing black, then what's happening is that pigment or dye is absorbing all the elements of visible light and not reflecting anything. You can have an object that does a bit of both for sure, and that's how we get the different colors. And then you can also have the possibility for transmission. So it can transmit, which means it can actually go through the object to the other side, which is possible with materials like glass, things like that. Okay, so let's look at the transmission one first. And these terms are familiar from grade 9 science, maybe before. I know you know them because we talked about this when we talked about physical properties of matter. So the three terms that relate to transmission would be if you have full, like all the light rays can get through, we call that transparent. So transparent means all the light rays go through to the other side. If something is translucent, like some of those like fogged bathroom mirrors, for example, that means that some go through and some do not. So we're getting a combination here. Some are being transmitted and some are being reflected in those kinds of windows intentionally. And then the last one is opaque. So in that case, it's sort of a weird one because it's basically saying this doesn't occur. So light can't be transmitted, which means it's either all absorbed or it's reflected, but no light is going through to the other side. So that's what's happening when we get the shadows, when I get the person right here, or with this little black card or square I put here, nothing shows up on the screen behind it. Okay, so I believe those words are familiar to you and you know what those means. We're now connecting them to light, not just from your understanding of when they were brought up in chemistry. For reflection, there's not too much I need to say about absorption. Absorption would be that the light goes in and it doesn't come back out and it doesn't go through. For reflection, there's a couple new things here. And then I'm going to be done my note for today. With reflection, it depends on the surface. Okay, so type of reflection. Reflection depends on the surface the light hits. Okay, so if you have a smooth surface, like a piece of metal, or a really calm, like lake or something like that, puddles, you can think of those in the road. What's happening is the light ray comes in and it'll come in for the purposes of reflection at an angle. So let's say it comes in like this, and we're going to do more on this as we continue with a couple other chapters. I'm going to do the arrow coming in here. The light ray, when it hits a smooth surface like this, will bounce back at the same angle it came in at. Try to represent that. And head back off again. People like to do this with the surfaces of their smooth watch, etc. So when you're in class, and like someone's trying to direct that light beam in your eye or whatever, that's what they're doing. They're taking advantage of that smooth surface. The light is coming in at an angle, which means it'll come in and bounce back off, and they've got the skills to mess around with it and try and get you. Okay, and blind you for a sec. So that's what that looks like. These kinds of surfaces tend to mean that maybe you can see your image in it. So the kind of situation where you're standing outside a store and you go to look in the window and you can't actually see through to the other side because there's so much reflection that you're just sort of seeing like you would a mirror of yourself back again. That's when a lot of reflection is happening, depending on where the sun is and the angle it's coming in at and stuff like that. Your book talks about if you want to see through to the other side, how you just like block out those light rays, and then you are able to see the light that's being transmitted through the glass instead of reflecting back at you. If you have a bumpy surface, okay, like a dirt road or choppy water or something like that, the light is not going to have this predictable in and out, okay, in and out. What'll happen is the light will come in, but then it will bounce off at different angles. So if this one hits here, maybe it's going to bounce off like that. Another light ray coming in. Maybe this one bounces off like that. Another light ray coming in. Maybe it bounces off like this, but it gets all scattered. So this is called regular diffusion. Wait a minute, I think here. Yeah, regular reflection of the light. And this is called, let's just take this, regular reflection. And this is called diffuse reflection because it spreads out and it's not angled in any particular direction. All right. So that's a quick summary of the topic for today. If you have your textbook, it's 10.3. I may or may not attach some pictures of the textbook pages today, but I will attach pictures of the end of this section and the chapter 10 altogether, give you lots of questions to look at. And then you can ask me any questions you have about those if you struggle with any of them. And I'll attach some other things for Friday. And then on Monday, we'll do a Google quiz to just check how it's going and see if you can answer some quick things off the top and double check for yourself and for me your understanding of the material. Okay? I feel like there was a show, probably you are way too young to have heard. I'm thinking it's Polka Dot Door. I could be wrong. Where at the end they used to like show this circle and there was different colors and then they'd say goodbye and have all kinds of kids' names like, you know, goodbye Porter, goodbye Sarah, goodbye Ella. Feel like maybe I should do that. And I'd feel like I'm actually talking to you. Maybe I should also start yelling at you for having your cell phones out and being late. All right, so you will see the work attached. I hope you have a good weekend, whatever that looks like. And feel free to send me questions, and we'll carry on with this pattern next week. Monday, Wednesday, Friday, mini lessons. Tuesday, Thursday, you can come check in if you want on the Google Meet and say hello and let me know how things are going. All right? Okay, thanks, everybody. Till next time. Oh.